Okay, let's start. Now, last day we found the histogram of a normal image. Okay, normal means a typical image you should where in any image the portion of the number of pixels for black and white colors are more or less evenly distributed. Okay, now the same image, if we overexpose to the light and underexpose to the light, you will get sorry, different pictures. So just I want to show you, just see this thing. It's a printout of this. I will give you the PDF copy of that particular thing. Say it was our, so this is the image of our department. Okay, and that is the normal histogram. Okay, in actually black and white, if we see, we'll see that the histogram will be something like this one. Okay, here the blue color, actually it is really not blue, it is just white, but for our understanding it is made white, blue. So if we see the histogram, we'll see that it looks like that. As there are a lot of dark picture, dark parts, so number of pixels for the dark color is much more. For the white part also, there are some pixels available, number of pixels, but relatively less. So that is the histogram of that particular, the front view of our department. It is a picture of few years back actually. That is the thing. Now it has been changed a little bit. Now if we overexpose it with the light, it will look something like, okay, our normal image is something like, here things are evenly distributed. Okay, but here it will see that if we overexpose it, number of pixels towards the black, towards the white part will be somewhat more. It will be something like this one. And it is the example that if we overexpose it to the light, so you see the number of black colored pixels are all absent here. You see no black, but the number of pixels for the white part is much more. Okay, so that is the histogram is shifted to the right side. Now, if it is underexposed to the light, same image, then histogram will be something that it will be shifted left towards the black part. So it is just the underexposed input image. Its histogram is something like that. This more towards the black part. Number of pixels are more for the black color. Okay, so that is this particular thing. I will give you the PDF copy of this particular page also, don't worry. Okay, now what we want to do, we want to enhance the contrast of the image, okay, by, okay, equalizing the histogram, so that any image that initially is not looking good or not looking clear, we can enhance the contrast and it will look good now. So what is the method? So our next heading will be contrast enhancement by histogram equalization. Contrast enhancement by histogram equalization. Okay. Now we consider that let the input and output histograms, okay, may be related by, so I write let the input and output histograms may be related as, what is the input and output? We give one image to our mathematical operation whose histogram is something, and now that histogram, we call that the histogram is some HA versus A. Now A is transformed into the B Okay. Okay, and then we get a new histogram, HB. So HB is the histogram of output image. So it will be something like, don't draw any picture now. Let me draw it first. আরো 10 মিনিট পর মিনিট 10। Actually, this is your vertical line, but my picture is not correct. Okay. So what is that particular thing? We have one input image whose histogram is something like, okay, it is obviously see that you can see that it is a overexposed image. Now we want to convert it, that histogram, into that particular thing. Okay, but not arbitrarily, following some function. It is a transformation from A to B, where B equal to FA actually. Okay, so it is A to B. So this way actually we want to transform it. Okay, so note that the number of pixels here, the mathematical function is that is the transformation function. How we can transform from A to B, A to FA, that is there, that is given here. Okay, that is the thing. And we assume that the number of pixels, so one more thing, there is a Q here. I should write Q and HQ. Okay. And this point is, this point is Q plus delta B. So number of pixels in the shaded region here. that is in between Q and Q plus delta B is same as the number of pixels in that shaded region. That is in between P and P plus delta A. So these number of pixels here and here, these are the same. Okay. So we are writing that our requirement that the number of outputs having gray level between Q and this P and P plus delta A, this okay, it was, so I get repeatedly phone call and getting disturbed all the time. সকাল থেকে শুধু ফোনই এসে যায় ঘুম থেকে ওঠা বাকি. The number of output pixels having gray level between this shaded region and that shaded region will be equal. Okay, between Q and Q plus delta B equals the number of input pixels with gray level between P and P plus delta A. What I told you. So as transformation is performed on point basis. So a point basis means it is a A to B point by point transformation. But in a close vicinity of any point P and any point Q, the number of pixels are same. Thus, delta A, you can write this is the width is delta A into HP equal to delta B into HQ. Okay, if delta A and delta B are small, obviously. So we are taking a small region. Yes. Now, so we want to improve the histogram so that the output histogram will be something like a flat image. So to improve contrast, the histogram of the output image may be assigned a flat shape as what is the thing? What is the histogram of output image? I am showing it in the next page. We want that this will be our HB and this is our A. Sorry, this is our B. This is D minus 1. This is A by D. Some value A by D. Here, what is the area of the image? It is HB is here B equal to varying from 0 to D minus A equal to, now HB its value is A by D. We take A by D outside, so it will be what? So it is added D times. So that is A, the area of the image. So what is that? If A is the area of the image, we are equally dividing it among D number of steps, D number of levels. If A is the area of the image, we divide it among D number of levels. So total area now will be equal to A. Now we know from relation, delta A into HP equal to delta B into HQ. Actually this particular relation, we are using that relation, that the number of pixels in the shaded region are equal. Okay, we can write delta B by delta A equal to HP by HQ. Now, what is, we know B equal to FA, so delta B equal to delta into FA as B equal to FA. We are transforming A to B, that I told you in the last class. I told you in the last class from A to B, so it is that. So delta B equal delta FA. So that's what we do. We write in place of delta B, we write delta FA. Delta FA by delta A equal to HP by, okay, now HQ. Now what is HQ? Now HQ equal to A by D for flat histogram, as HQ equal to A by D for flat histogram. So HQ is what? Actually this is the output image, it should be flat. We want that it will be flat. So HQ equal to A by D for flat histogram. Yeah. Or we can write delta FA equal to D by A into HP delta A. HP delta A. Now what is delta? It is the change in A. Now delta A equal to A minus 1. Any variable A minus 1. Considering quantization of gray level, which is equal to 1. Delta A. And what is, because why? Because all the gray levels are changing by one amount. 0, then 1, 2, 3, 4 up to capital D minus 1. So I write it capital D minus 1. That was, so it stays, the step is 1. So ultimately delta A equal to 1. So therefore what happens? So delta A, okay, and what is delta FA? Delta FA equal to FA minus FA minus 1. Okay, that is this particular thing. Now we put this value delta FA here and delta equal to 1. Okay. Okay. Then we can write it is what? It is FA minus F A minus 1 divided by 1 equal to D by A into HP. So that is the relation. Now we want to sum from 0 to A. So now summing from 0 to A, what we get? Summation FU minus FU minus 1, where U is varying from 0 to A. So we are summing them. This is equal to what? It is, okay. So it is D by A is common. Okay. So D by A is common. We can get it. Summation HU U equal to 0 to A. Okay. So just we are putting this. Just U is any variable. You can write P also, no problem. You can write P also, no problem. Okay, so when we add them from 0 to A, what we get? FA minus F. Now what happens actually? You add them. You see, when U equal to 0, what happens? F0 minus F minus 1. When you write F1, U equal to 1, F1 minus F0, F2 minus F1, F3 minus F2. So the previous value of U, that is U minus 1, will be cancelled by that particular thing. So if you add them, only the last value and the initial value F minus 1 will be there. Get my point? If you don't understand, then I'll explain it. Or if you understand it, no problem. So finally, after adding, we get this particular thing. Or D by A equal to, it is what? It is capital A of small a. That is the total number of pixels for the variable A. Okay, it is that one. But F minus 1 is 0. And this is what? It is AA is what? And AA is it is a cumulative histogram. I already told you in the last class. So between 0 to A, any A, if A is the last point, D minus 1, it will be the total number of pixels. But if it is any intermediate A, it will be the cumulative histogram. So we write it AA. Therefore, we can write FA equal to D by A into AA. So we write it in the next page. So page number 3. So it's 0. So FA equal to D by A into AA. So it is. So thus we can write our AFA equal to D by capital A into AA. Okay, so that is our relation. That's how we are getting FA. So the cumulative histogram up to the point A into D by A will be our changed function actually, FA. So we can write thus from the relation from the relation the output pixel gray so the transformation function histogram for the input gray level A of the point XY of the input image. Of the input image. So that what I told you is written here actually just for your benefit, and the histogram will be totally changed now. So just I want to show you, I will show you this PDF. So this is our original image and that is the histogram of the that is the image whose histogram is equalized. So from dark image actually we are getting another image whose histogram is equalized following that particular technique. And see, you see that the histogram of that original image, which is much dark, and the number of pixels in the black region is much more. Now, after equalization, we are getting contrast enhancement. We are getting more contrast, and the number of pixels are more or less distributed. In this particular way. So that is the method actually. That's how we can improve the histogram also. There is another picture I can show you. Okay, that is the original image which is overexposed to the light. After contrast enhancement, you see that one. So here the histogram is more or less towards the white region, but here it is more or less equalized. This, if you want to know more about this digital image processing, the best book is the Digital Image Processing by Gonzalez and Woods. That is the best book. And if you want to do some experiments on you, by you, then you can get the book by there is another book of by Gonzalez and Woods, which will be Digital Image Processing with MATLAB. Digital Image Processing with MATLAB. It is by Gonzalez and Woods. That is a second book. So here just you can do a lot of things on image processing using the MATLAB if you follow the second book. So that's a fantastic book. So any question today? So that is the end of this particular class. I need one more class. That will be a class entirely on PPT. Okay, that will be entirely on PPT, but before Puja vacation, I'm not sure Monday possible or not. What is the Monday is Shoshti or not? Which one? কেউ বলবে মানডে কি ষষ্ঠী নাকি টিউসডে ষষ্ঠী?
স্যার মানডে ষষ্ঠী আছে।
মানডে ষষ্ঠী?
হ্যাঁ স্যার।
ও তাহলে ঠিক আছে, তাহলে পূজার পরে
আওয়াজটা শোনা গেল না, আরেকবার বলবেন?
আমার আর একটা ক্লাস দরকার, বাইরে আসলে খুব বৃষ্টি হচ্ছে ওই জন্য আওয়াজ হচ্ছে। যে বলছি যে আমার পুজোর পরে আর একটা ক্লাস দরকার, যেটা হবে পুরোটাই পিপিটিতে আর কি। ঠিক আছে,
ঠিক আছে,
পুরোটা পিপিটিতে হবে, তাহলে আমার সিলেবাস কমপ্লিট। সুতরাং পুজোর পরে তোমাদের খুলছে কবে?
আমাদের স্যার 25 তারিখে।
25 তারিখ খুলছে, একটু যোগাযোগ, একদিন বসলে হয়ে যাবে। ঠিক আছে,
আচ্ছা স্যার।
তো আই লাইক টু কনক্লুড টুডে। আমি এক্ষুনি মেটেরিয়াল পাঠিয়ে দিচ্ছি, ইনক্লুডিং দ্যাট ফটোগ্রাফস অলসো।